All right. So, hi everyone. Good morning, good afternoon, good evening. Before we move and start our presentation, I would like to ask a question. Can AI enhance human creativity? It may be yes, no, maybe. But before we make that decision, we would like to walk you through what are some creative applications. And one caution I would like to share is you might want to hold your seat tight because some of the applications are so exciting and creative that you might jump on your seat. So let's start with a few examples. So the image on the left is Sketch RNN implementation by Magenta, where one can sketch, and on the right it will generate what are different possibilities to develop and enhance that sketches. So this can provide some insight which the human mind might not have thought of before they started that exercise. On the right, these are some of the applications the artist community is applying. It can be Deep Dream, GAN, and various other ways to enhance and create art which the world has never seen before. On the architectural side, these are some of the exploration where a style GAN model was trained on building floor plan. So it can create some hybrid combination of a plan which is not precedented. This is on the architectural section exploration. Yeah. So before we start, let me turn on my smoking GAN mode on. Okay. All right. So what we want to do is we want to provide a workflow where one can explore various design explorations using ML. So it's facilitating childlike imagination. So as you can see on the left, there are various input images for style transfer. And one is not limited by a particular domain. It can be architectural, artists, even robotics, psychedelic, anything which one can do a hybrid style while transferring on the content image. And moreover, we want to take the application in architecture to another dimension by combining different machine learning models. So not only like one is deploying a style transfer model, but using the output of that machine learning model, one is taking that as input for depth map creation machine learning model. So in a way, uh, different type of creativity is enhanced using different machine learning models. So few of the ways one explored various design options is either parametric models or physical models or digital models. But what if we present you a workflow where you can generate n number of design just by selecting different stylistic images, and it will generate different types of 3D geometry, which is very creative in its own sense. So let's introduce the gang. So we have Sergey Pigash, applications developer from TT. We have Sergio Guindan, structural engineer from Cyrus Structural Engineering. Mayur Mystery, myself, I'm art student at University of Illinois, and Charles Portelli, applications developer at TT. So I'll hand over to Sergio.
Cool. Well, hi everybody. I'll take over in just a moment. And here we go. Hopefully you guys can see my screen. So as you can probably tell by now, we kind of took a bit more playful approach to this issue, trying to not really provide a solution, but kind of a platform for messing around and really asking the question of what if, right? And doing it quickly and then in an iterative fashion. So here, just a quick live demo, just to show you what we've made before we explain what it is, but hopefully that works for everybody. So we came up with the Grasshopper plugin that is able to interact with a Flask server that is currently is very, very busy on the local host of yours truly. So what this script is currently doing is trying to pull different images that we referenced in that component, and once it's done doing it live, we'll talk about the results. But essentially what we have here is a Grasshopper plugin for interfacing with different GAN related models. Okay, so in a moment. It's going to think a little bit more, and we'll have some results. Yeah. So what happened here, right? So originally we have, just a generic picture that can be anything, preferably based on the checkpoints in the data sets that we've been using, something related to either everyday objects or architecture. And then we have some utility components to pull out a bitmap out of this image. And then we have a component that basically allows you to interface with the style transfer GAN that can quickly transform this image into something maybe not structurally different, but visually quite distant from the original. And you also can choose between different pre-trained models. And that is combined with a different route on the server that is responsible for generating the depth map. So the depth map, usually this is something you would get from like a stereoscopic image when you take, a picture from two directions, and then through sophisticated algorithms, you can figure out how far the objects are from the camera. But in this case, this is a trained model that basically just does it also by using GAN. So this way you can just feed it one image if you don't have a stereoscopic representation of something, and it will do its best to try to estimate what that is. And here we have some components for just basically rendering those images to the screen. And then we have a component kind of combining the two and trying to kind of extract and remap that depth information into the 3D space. So that would probably best be illustrated with an animation that I can show you here. So again, and for some reason we're really jumping slides. Okay. So the good thing about working with GANs is that you are really expected to provide really simple inputs, right? So here, for instance, you see a portion of the animation that explores the, kind of this inferred inferred depth from a series of film stills. So here again, we can see that we have our original footage that doesn't have any sophisticated associated metadata with it. It's just a drone footage flying over the street. We have sort of a stylization of this running on the bottom left, which we'll hopefully get to see. Yeah. And then we're able to extract depth information from both the stylized image and the original footage. And just to talk about the technology really briefly, I guess the previous team's done an exceptional job explaining what GANs are, so I'm not going to go over this once again. But in case of the style transfer GAN in particular, the task of the generator is to generate a bitmap that is reminiscent of a series of reference images. So for instance, we can think of the image that you provide as a user as a content image, and then there would be a reference image that the GAN would do its best to match in terms of style and certain aesthetic and visual qualities. And these are just some more examples of the style transfer. And with regards to the depth map, again, so just trying to look at the two-dimensional image and infer depth information out of it. And then combining the two has really kind of been the purpose of this hackathon project, just trying to see what kind of experimental results we can get out of combining depth with different visual representations of common day everyday objects. And I'm going to hand it right back over.
So this is an input image, and and one can apply any style. They can select different artistic style and apply it. And moreover, like there are various other parameters which one can play with. They can select what are the convolutional layer they want from stylized image or style content. Even and to take it at another level, one can blend two different style image and create a hybrid style out of mixture of two, and that's how it can be forwarded to depth map, and different types of geometries can be created. So this was the initial vision which we started with, and we had envisioned that we'll work around with TensorFlow JS because of its lightweightness. But when we performed the actual in the operations in GitHub and like downloaded the original model, it didn't took a lot of time. So we thought of continuing that.
So looking at the high level process of how we started to kind of stitch all the pieces together, we started with this kind of flow with being able to take in some image data. We have set up a Flask server that sits currently on Sergey's machine, but ideally it would sit remote. And then there's a series of requests that are made to the server. This has the pre-trained data, the image, the weights, so on. And then there's a request that's made at the end once the data is formatted, and then we get a resultant image as an output. Go to the next slide. So this is just kind of a snapshot of some of the components that we created within Grasshopper, and kind of stylize them based on some of the features and functionality that we do, that the components do.
You actually just hit 12 minutes.
Okay.
Sorry, I didn't give you one.
Yeah. So the idea of being able to create depth, we also wanted to create void. So we actually took some of this depth map data and we're able to slice it apart so that we actually can now create voids within the three-dimensional space. And these are just some snapshots, some recordings of some of the outputs in Rhino. And then this is kind of a recording of it running live in case the demo didn't work, but obviously you saw it work real time. And this is just looking at the tech stack. We're using Rhino and Grasshopper as kind of our input-output display mechanisms. And then for the cloud-based portion, we're using a Python Flask server, and we're making calls to TensorFlow and some pre-trained models. Check it out on GitHub. Here's the link. Below we listed out, a few of the goals that we accomplished. Being able to deploy a TensorFlow JS model, being able to create custom components, and being able to basically send and receive data between those and have that data reside within the Grasshopper environment.
Can I just add, Charlie deserves some sort of award or beer or something, because my experience is not programming, and so that Grasshopper plugin thing was really something that he had a lot of patience there, slowing things down for me.
It's a gang effort. Let's put it that way.
Yeah.
So with regards to future goals, the idea we could look into is, how can we take other 2D data and transfer it to 3D data with also potentially some styles added into it? How can we start to look at, some of this generative planning capabilities? You saw a couple of examples in the previous two projects, layouts and so on. And then how can we bring ML to a more tangible kind of solution that it becomes almost common day usage, just as much as Grasshopper has become.
All right. Thank you.
So I have two questions. but they're separate. So we'll ask the first one first. Good, very nice. So we're looking at an image input that will then generate a style transfer and a depth map to output 3D geometry, which is, I think, is really cool for capturing. Have you looked at 3D input, then 2D input, and then a style transfer and a variation on that 3D model back again?
We'll do that
like
tomorrow.
Okay, no, just asking. Like maybe a 3D style transfer in a way, you know? So
yeah, no, it's an opportunity. It's interesting. It just takes time.
And there are some really exciting tools, like some time ago, PyTorch released a 3D library for machine learning, which is really, really cool. So yeah, there's definitely an opportunity there.
And the other question is, when you generate the 3D geometry back from the depth map, do you use Rhino's displacement tools, or how do you do that?
Just run a common API.
Okay. Look, I'm saying that because Rhino, it's a very computational heavy function, and the images typically need to be sort of 16 or 32-bit, but it's probably one of the only applications I know of that you can capture the mesh from a displacement. And you can generate really accurate models if you want at high res.
Yeah, no,
I just want to know how it works.
We're numerically generating the mesh ourselves.
Got it.
I'm happy to say that Rhino and Grasshopper were the only parts of that project that didn't give us any trouble. So.
Any more questions? Cool. Cool. All right.
Okay, Shannon,
yeah.
let me just shoot one here.
Go ahead.
Because this is number 4 of these.
He's got the coolest background.
French, you know, course. This is I feel that it's repeating a bit what I saw in the other projects here, and I was waiting for the right time to ask this question here. First of all, really inspired. I could use this immediately for one of the rave parties. I think it's really, really cool what you guys are doing. I have a question more on when I saw your future. You talked about like how can you implement this into something. Could you maybe elaborate a bit more on something else than just a floor plan? Something else that you can do with this? Something maybe bigger or more? Yeah. Just to get a bit of grasp of it. This is a bit different from the others. That's why it's quite interesting for me. So what did you talk about when you were doing this? That it's not a floor plan or something like that.
I think we wanted to look at a creative side of this versus an automation side of it, right? And this kind of goes to one of the comments that I posted in the Ring Central chat, is that computers aren't going to go away, but guess what? Neither are humans, right? You know, back in the days of Deep Blue and Kasparov, they were always kind of this kind of like dueling, and my memory is kind of fading me right now. There was always kind of like this, they were always kind of these dueling relationships between the two, but there was a point in time where they actually teamed up together. And they played chess together as opposed to against one another. And Kasparov at the end of that said that it was one of the more enlightening moments for him to play chess. You know, now you're talking about a master of an art teamed up with a computer, and he now saw a new light in terms of his what he was capable of doing, right? So the purpose, you could say, of this project is essentially to have computers enlighten humans as opposed to, you know, try to eliminate us or automate us or, you know, whatever, right? Because there's significantly more potential within a human, right? If we foster that. So these, you know, ML systems, if we can have them foster humans, we can reach higher goals a lot faster than if we just let the computer run itself and think that whatever the computer is going to generate is going to be like, you know, some amazing solution, right?
And I just want to add a comment to that. I spoke quite closely with an artist called Scott Eaton. I don't know if anybody's aware of him. He deals with photography and anatomy in particular, and he's trained a model to basically generate photographic content, art, based on the machine learning algorithm and his sketches, and he's done some really beautiful stuff to the point where he's taken it to 3D sculpture. To him, and his explanation is that it's not replacing at all. It is another paintbrush that he's using. It's another method of doing art. So he still generates the actual art. There's also an app out there you guys can go and play with called, I don't know if you're aware of it, GAN. Basically you're also painting flat colors and it generates photography. But again, the photograph is not, it is exactly what you input, but just interpretate or transferred as such. So yeah, I think it's great. Awesome.
Yeah. Lastly, to conclude, one of the goal was to deploy the machine learning algorithms for artist and architect community in their current workflow of Rhino Grasshopper. So even for their day-to-day explorations, they can, instead of going and depending on other softwares, they can deploy it